Cool. Just checking sound. Cool. Just checking sound. Looks like we're connected. We still have another minute until class is starting up. Ooh. Just checking in on, looks like we have some people joining. Views? 0 views. I mean, it says there are 2 viewers, but I don't know. I'm just giving us a couple of minutes to kind of get settled into the live stream setting. Thanks for joining. If you are joining or you're watching later, thanks for joining via online method. I'm just gonna restart. Clear all that. Yeah, not ideal, but it's nice that we do have this option since we're already connected to the World Wide Web through our streaming. And as people are kind of getting settled and catching up on the live stream, at any point, so I'll leave the live chat up here, so at any point if you have questions, I'll keep monitoring this to answer questions as they come up, and I'll try like just going through my own analysis of things that I've noticed over the years of working on this stock exchange random walk predictor model. And the other plug is github.com/CooperRC. Don't forget that we do have our discussion board where you can post questions about anything for the course. It's especially helpful for like troubleshooting problems. So let's see. Oh, like this. 404 not found. This is a problem that a lot of people have had, and the answer is that in that link to the stock exchange random walk predictor, I forgot to add that .md to that file name. So there's a video solution here on the old YouTube channel, but also if you go into this notebook, so analyze data brings you into this page. Usually this .md is not there. So when I try to go to this link, it brings me to a 404. But if I add that .md to the end of the link to say like, no, I want to go to the markdown page, not just a non-labeled page. But anyway, so you can use this in 2 ways. One, you can do a search for, just close that out and say like homework 2. And yeah, so people are asking questions here about like homework 2 part 2b. Oh, this one didn't get answered. Sorry, Sean, but but a lot of times we do have answers. But anyway, always don't forget about that that place where you can always post So you can always post on the discussion board, and help each other. Like if you see a question come up, then pop in there, offer your approach to it. And how are we doing? We have a few viewers. Nice. Thanks for joining. And there might be more. I don't know how quickly YouTube updates all of this. But what I thought I would do is run through the process that I would use to do this project, at least if it was me working on it. And at any point, post in questions. We can either switch gears and work on something else, or kind of dive deeper into specific questions. Whatever comes up is totally fine. All right, so running through, first thing to do is just run through this analysis, make sure that it's working the way that it should be. And if it's not, then we'll jump in and troubleshoot it, figure out what the errors are, load the data in. So now I've got 851,000 rows, 7 columns. The Google data is getting split here at 2014, like March 2014. And there's, is this working? It did not work. Why not? Interesting. Inline? Strange. Huh. That's why it's good to make sure everything's working, right? Okay. Anyway, okay. I think before I was playing around with this magic command to try to get like interactive plots, but I haven't been able to get interactive plots to work, and I'm not really sure why. I don't know if it would help to change it to a later kernel. But I'm just going to leave it as is. I don't need interactive plots today. Okay, and I'm just holding shift and hitting enter and kind of running through this stuff. Seems like it's working. Cool. And here I've got predictions 2010, 2014, and showing what the rest of it is doing. Gonna delete that. I do get this kind of set params thing, but that's all right. Oh yeah, that was something that we were playing with. So I'll get rid of that. Okay, so now I've got like model here in red showing what the predictions are versus this black line showing like what the actual stock exchange did for Google. I have my own like kind of analysis there of saying this, but let's choose a new stock price and see what's going on. What is Intel stock NYSE? What is it? INTC, that's what it is. Let's try that. So I'm gonna grab some of the, yeah, let's take this one. I'm just gonna copy that whole cell, and you can click this copy button, or a copy is a C on the keyboard, and then paste it down here. All the way down. And sorry, I know I'm scrolling up and down. let's change this to Intel. Ooh, if I could spell Intel. And I'm going to change it a bunch of times. And I think it's INTC, like that. So I'm going to hold Control and keep changing this. INTEL. Intel data, and let's just try it. I'm just going to run it the same way that I had run the Google data and see what happens. And here I've got this red line showing all the data that could be, that I could, like now it's split into pre-2014 and post-March 2014 data. Whether or not I think that's a good fit is, or enough data or not too much data, is, that's kind of up to you to decide. What I'm going to do is do more of like a training, testing, data split, and this is kind of like good practice for like data science kind of work. So I've got 7 years worth of data. So roughly I want to take like 80% of that and use it as my training data, and then 20% I'll use that as my testing data of like, can I predict 20% just by using 80% of this? So rather than, so let's see, 0.8 times 7 is 5.6 years. So somewhere here in like 2015, maybe we'll call it like July 2015, I'll split that data up. So 2015, 07, July 4th, just why not? And we'll call this like pre-2015, pre-2015, pre-2015. And so the reason that I'm doing that is that I have kind of nicely formatted data. I have a date for every time. Like I've got all this information about each part of this data set. So if I split it up into just data that I want to include in training the model, then I'll use that to train it. And then the rest of it I can use to test the model, of like extrapolating outside of where that model is. And 80-20 is a good split. 60-40 is even better. Like you have more stuff to split up, but that would be back in 2014, probably about what we did for Google. But yeah, again, it's up to you if you want to split it and how you want to split it. But this is a good way to do data science kind of stuff. And if someone asks like, how do you deal with data? This is a great way. I split it and use the training and testing process. So I'm coming back up because the next step is I want to see, is this data kind of, this line to me looks like it's random noise, and I want to check to see, is the Intel data the same thing? So every day, because that's the random walk hypothesis, is that every day the change is just going to be random. So we're going to do this and that in, oh wait, did I use capital I or lowercase? Lowercase, my bad. And here I want to say 2015, 2015. Just as a quick note, when you take the difference of something, you lose one, your vector is one shorter because you need at least 2 values to take a difference. So I'm starting at the second day rather than the first day. And looking at this, maybe you could convince yourself that there's some kind of signal in there, or that there's something non-random, but to me, at first glance, this looks random to me. Like it's not, in this case, I could kind of squint and say like, maybe this is a parabola and that's a parabola. Like maybe I could start fitting some polynomials to this And with a high enough order polynomial, I could create an exact fit to all these data points. But in this case, a polynomial is just not going to do it for me. Like, it's not a straight line, definitely not a parabola. So there's something random about this. And I don't know what the randomness is, but I can start with a normal distribution. So I'm going to come way back up here, and I'm going to take this. Actually, let's just do this. I'm going to hold shift and select a couple of things and copy all of these all the way down to the bottom of what I'm doing so far. Paste them all down here. And let's just combine these two. Shift M is going to combine them. So my D price is what I just calculated up here. It's going to have, I'm going to look at what a normal distribution is compared to all these. And this is going to say Intel changes over 5 years. So let's look at that. And so I've seen this a lot with people's work where they take the existing code, then they try to use it for something else, and now it's like, well, what does this mean? Like, how come this looks so different from what I had seen up here? Like, why is my plot so different from this Google plot? And if I look at the scales here, like, this is like 5%, 5.5% of the time, or whatever. Yeah, 5.5% of this data is around 0, and there's like 0.05 around like -20. But if I come down here to where I just plotted this, here, nothing happens at -20. There's no change that ever got to -20. Like, everything is happening within $2 to -$2. So I want to change this. I don't want to look at -40 to 40. I want to look at 2 to 2. And just to look at a little bit extra, I'll look at 3 to 3. So I'll capture like everything. And now it's zooming in a lot closer to the actual like spots here on my process, on my data. And you can change this number of bins, like 30, 50, whatever number. Kind of, a lot of times you have to play around with it to get it to the point that makes sense to you. 50 is probably about right. And here, like up at the top, I don't have a smooth normal distribution, so I'm going to change this, make it 100, just so I have a smooth normal plot and I can see how well it matches up. And it looks like this left side is pretty good, and then the right side has more of a step pattern, so maybe there's some other distribution that might fit this histogram a little better, but I don't know, it doesn't look bad. And overall increase in Intel price over these 5 years was 1 cent per day, so $3.65 every year. But standard deviation, it could have been 37 cents, or it could have been negative 37 cents, with 65% of those days, kind of. And then I don't need to recreate this one. I'm gonna use the same random numbers, number of models. I'll stick with 100 for now, and now I want to change this to my, oh no, I used lowercase, oh my god, Intel pre-2015. Oh, unindent, what? Where? His step. his type. What's your problem? You're all within a... Oh, I must have deleted one of those at some point. No? Something wrong. Oh, in here. Oh, length. L-E-N. I deleted one of these. Oh my god. Alright, so what was happening, if anybody is interested of like, how'd you figure this out? It was telling me that there was something wrong way down here, but it just doesn't make sense. Like why, there's nothing wrong with having multiple lines there. So somehow during my copy and pasting and editing, I had messed up opening and closing parentheses, and that can be really hard to like dig down and figure out. So I went back, and when it highlights the two as green, it's showing you the open and close. So I was going through and making sure that each of these had open and close, and this thing is supposed, the size is supposed to be a list or some kind of structure, like an X by Y or M by N sort of thing. Well, you can make any size you want, but anyway, now it should work. Sure enough, it does work, but I see this a lot in people's projects where as they're trying to figure this out, they have a model prediction that looks way off, like it's so different from their data and this like best fit to the data, or at least a fit to the data. And the reason for that is that right now that location and scale, these represent the mean and standard deviation of this random number generator. So right now it's still 56 cents, which is 56 times our average, and it's still 983 or 984, which is like 10 times more than this, or like 50 times more than that. So what I want to do is take these two values, let's print them out. Print mean D price, and you could just plug these in directly into D price. But I'm going to take those two, print them out, and paste them right into here. Paste, and delete, paste. And you could just plug those variables directly in. I just wanted to show that when I do that, my model prediction matches this red curve pretty much exactly. It's going to be it has to be different because these are random numbers and this is an actual like distribution, like normal distribution. But if I had more days, if I increase the number of days, then I would end up with the same normal distribution. And cool. Oh yeah, and let's change this. Intel changes over 5 years. Now I'll come back up and let's start looking at our predictive price. So I'm going to take just this line where I'm setting up my price model as that cumulative sum. Paste it up here. And I don't need that. I need Intel pre-2014. I'm going to add it to that value there. And now I'll come back up here and I want to grab this so I can look at that same kind of error bar plot. Just like that. And right now I'm doing cumulative sum of that D price model, which is what I set up here. with this normal distribution. Hello, hey Ethan. And oh, we're online, bud. We're recording. And I want to remove all this Google stuff and change it to Intel. Oh. Intel, I think it's data pre-2015. So I'm just doing a bulk edit, like multiple lines at a time. And I want to look at, just see how that looks to start. See if I get any errors.
What does this stuff mean?
And now at every model, no matter what the D price was, like as time went on, they all had to start at the same 22 bucks. And then as time goes on, the error bars keep getting bigger. But I'm always within, in this case, less than 1 standard deviation of these predictions. But keep in mind, I used every one of these data points to create the mean and standard deviation. So it makes sense that the changes in price will predict that the average changes will all be the same here. Now, what I could do is extend this model. So take away this pre-2015 and create a prediction. I'm not changing my location or my scale, so average and standard deviation are going to stay the same, but I can start predicting into the future and compare it to data that I have. So now I want to look at my price model for all those, and I want to plot the Intel data, so all that Intel data, and that's my stock exchange data. And now I can get rid of this and look at that price model average, standard deviation. Cool. And now past this point, this is my last data that is part of my training data. Everything else is predicted. So 2016, halfway, and then all the way up into 2017. All of these are values, and they're within half a standard deviation. So I've created a very accurate model that the average value is going to follow. The average value is following the trend of this Intel data almost exactly, but it is not a precise model, because by this point I'm predicting the price is going to be maybe $30 plus or minus $10 to $20, which is almost like half of. And here let's take a look at if we just look at what the price model average is. And we'll look at Intel data date. So here's my predictions. Roughly it should be 1 cent per day, so $3.65. So it went from $20 up to $32. And if I increase my number of models, so here, change this, because this is the best way to make sure your Monte Carlo model is doing what you want, is just keep increasing the number of things. You're throwing spaghetti at a wall to see what sticks, so throw more spaghetti. And there, now I've got 5 times as many curves back there, and I can see now as I take even more models, for the most part it's a straight line increase, that the average is just going up. So by the end 2017, I'm saying that it's 32 something, and the actual price date and the actual price was like 35. And really an even better way to zoom into what was the difference between the two is actually look at the difference, like what was the average minus that Intel Open data. So it starts off exactly at 0 because that's how we have to start. And then as time goes on, it kind of goes back and forth. Like our average prediction is roughly increasing, but things were dropping. So we were $4 off here in 2012. We were $8 off, $8 lower, or well, we predicted $8 higher than the actual price. But now in 2017, we're only like we're within $4. And if I want to look at like relative, here, let's plot this. My standard deviation kept going up over the years. So I could look at the relative price there, like price, model, standard deviation, take each one of these and figure out how many standard deviations was I away from the prediction. And here, again, for the most part, I'm never more than 1 standard deviation away. And out to 2017, I'm only a quarter of a standard deviation difference. And very accurate. So we're always pretty close to the right answer, but not very precise because our answers are can be $16 off when the actual prices are 30 something dollars. So roughly 50% off in all the different cases that we had calculated here. But that's how, at least if I was approaching this project, these would be the things that I would look into. And I know I made the project, so there are certain things that I like to think about that maybe you hadn't thought about. But this would be a great way to start, of what is, split the data at a point that you want to. 80% is a good number. 60% is also fine. And then start trying to make some predictions and talk, and you should add, like down here, you can add some, you can insert or change the cell from code to markdown, so that now you can say, like, my predictions for 2017 are and here now I need to say price model average bracket -1 32.27, and the actual price was I think I can do that. No, it doesn't like that. Actual price was $36.79. Oop. This is an error of $4 less than, well, $4.50 if I can do math. 36.79 minus 32.27. Yeah, 451. This is a very accurate prediction within, and what did we say? 0.25 times my standard deviation of prediction outputs in the Monte Carlo models. This is not a precise prediction. If I could spell, because the standard deviation was D price, or price model STD .49, which is 36.79 over that is, oh wait, 42.1% of the actual NYSE data prices at that time. So this is a great way to kind of talk about like the some caveats here of like, is this a good model? Yes, because it's very accurate. Is it a reliable model? Like, kind of, but it's not very precise, because if I'm telling you price is definitely going to go up by $1, you're like, okay, well, how confident are you in that? It's like, well, it could go up $1, or it could go down by $12. It's like, wait, what? That's a that's a very big difference between these predictions. So accurate, not very precise. And you can take a look at the actual like changes, like what were the differences in price over time. And interesting, at least to me, it's kind of interesting, like even within this data that was part of our training, like we still have kind of large errors. And even out to here, like all of this was included in our D-price model, but then out here, we're kind of settling back into steady state errors there. Or if we really want to get fancy, we could do like a PLT dot box plot of those differences. And now I could say average error was something. I don't know. I would probably like take the average in the quartiles, but lower 25% was -$2, upper was about $2. But yeah, we can do all sorts of cool stuff if you want to dig a little deeper into these predictions in this model. Cool. All right, so I've been rambling. Hopefully this is helpful if you're either watching this live or you're watching a recording later here. Don't forget, like if you're running into trouble, you can always use the discussion board here and open up a new discussion, or do a search and try to figure out like what other people doing. Like, there's probably some questions about Monte Carlo that have been analyzing Monte Carlo, building Moore's prediction. Oh yeah, so it's a good resource and good place to work there. And I haven't seen any questions. It looks like we do have viewers, so if you do have questions now, I'll wrap up for the day because I've just been rambling. And yeah, I guess that's it. We'll be back in the classroom on Wednesday, and we'll start off with module number 3. Cool. All right. Thanks a lot. Have a great day.